In this lesson, you'll learn about the properties of parallelograms. The objective is to use relationships among the sides, angles, and diagonals of parallelograms. So what is the definition of a parallelogram? A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So in a quadrilateral, what are opposite sides? Opposite sides do not share a vertex, which is the point where sides come together, and opposite angles do not share a side. So if you'll look at the diagram here, we have segment AB and segment CD are opposite sides because they do not share a vertex. And if you will look at sides BC and AD are also opposite sides because they do not share a vertex, the point where the sides come together. And the opposite angles, we have angle A and angle C are opposite angles, and angle B and D are also opposite angles. And we will learn, when we're learning the properties of a parallelogram, that opposite sides are congruent and opposite angles are congruent in a parallelogram. So let's look at the next theorem. Here we have several theorems about the properties of parallelograms. The first one indicates that if a quadrilateral is a parallelogram, then its opposite sides are congruent. And the next definition is consecutive angles. The angles of a polygon that share a side are called consecutive angles. Now, if a quadrilateral is a parallelogram, then its consecutive angles, angles that are beside one another, are supplementary. The next theorem says that if a quadrilateral is a parallelogram, then its opposite angles are congruent. And the next theorem says that if a quadrilateral is a parallelogram, then its diagonals are going to bisect each other. And finally, this last theorem says that if 3 or more parallel lines cut off congruent segments, on one transversal, then they cut off congruent segments on every transversal. So in this diagram below, we have parallel lines and 2 transversals that are cutting through those parallel lines. And if AC is congruent to CE, then BD is also going to be congruent to EF in this diagram. So let's look at some examples. First problem asks, what is the measure of angle R in parallelogram RSTU? Well, R, and we know the measure of S is 71, and R and S are consecutive angles by definition. because they are angles that share a side. They share the side RS. So that means that they are supplementary. So the measure of angle R plus the measure of angle S has got to equal 180. Measure of angle R plus measure of angle S is 71. And subtract the 71 from both sides. So the measure of angle R is 109. In problem 2, using properties of parallelograms in a proof, we're given that parallelogram, we have two parallelograms, ABCD is one, that's the larger parallelogram. And then we have a smaller parallelogram, NMLB, that's nested inside of it. And we need to prove that the measure of angle M is congruent to the measure of angle D. So to do this, we need to start with what was given. So the first statement that we can make is that quadrilaterals, ABCD and NMLB are parallelograms. And you can use this symbol for parallelograms instead of having to write it out each time. But that's given. And statement 2, because they're parallelograms, and the theorems that we have over on the left side, we know that opposite angles of parallelograms are congruent, so we can say that angle B is congruent to angle M, and we can also say that angle B is congruent to angle D. And the reason is because opposite angles of parallelograms are congruent. And so from that statement, we can make the statement that we're trying to prove that angle M is congruent to angle D because of the transitive property of congruence. If you remember, that says if A is congruent to B and B is congruent to C, then A has to be congruent to C. So here we're saying if M is congruent to B and B is congruent to D, then M has to be congruent to D. So that's transitive property of congruence. In problem 3, we're using algebra to find the lengths of segments within the parallelogram. We're actually asked to find the length of HJ and IK, which are the diagonals of the parallelogram. And we're going to use a system of equations to do that. So you need to remember how to solve systems of equations from Algebra 1. Here we're going to use the properties of the diagonals of a parallelogram. We know that the diagonals bisect each other, so that means that these two diagonals are congruent. So we know that A, in our first equation, A is equal to 2B minus 8. And then in the second equation, we're going to look at this other set, this other diagonal that's bisected. So in our second equation, we're going to look at and see that A plus 2 is equal to B. Just because the diagonals are bisected, we can set those two segments congruent to each other. So let's use substitution in this. We know from the first equation that A is equal to 2B minus 8. So we're going to take that value for A and substitute it into the second equation to give us a new equation, which is going to be 2B minus 8. That's what we're substituting in for the A, And then bring down the rest of the equation. Plus 2 is equal to b. So if you solve this, subtract the b from both sides, and so you're going to have b. Let's combine like terms here. You're going to have b minus 6 is equal to 0 if you subtract the b from both sides. So b is equal to 6. So we've solved for b, but that's not what it's asking for. It's asking for the lengths of hj and the length of ik. So we have to substitute this value for b back into these equations. So we need to find the value of a, and since we know that a is equal to 2b minus 8 from the first equation, we know that a is equal to 2 times 6, since we know now b is 6, minus 8, so that's 12 minus 8, which is 4. So a is 4. So if we look at the length of hj, for hj we would have to add together the segment that's a plus the segment that is 2b minus 8. So for that we would have the a is 4, the b is 6 minus 8, so the length of this would be 8. For ij, you can add together ik. For ik, we can add together the a plus 2 plus the b. So we just said a was 4, b is 6, so that is 12 for a length of ik. Last problem, we're using parallel lines and transversals. So in the figure below, it tells us that our W is parallel to SV, so we'll put some parallel markings on that. RW is parallel to SV. And then it also tells us that SV is parallel to TU, so I'll put a different set of parallel markings to show that relationship. SV is parallel to TU. So if the length of RS is 5 and the length of ST is 5 and the length of WV is 7, what is the length of WU? So WU is what we're trying to find. So we need to know what VU is, because WU is going to be equal to WV plus VU. And from the last theorem that we had in this lesson, if three more parallel lines cut off congruent segments on one transversal, so these are congruent on this side, the 5 and the 5 are congruent, that means that it has to cut off congruent segments on the other side as well. So that means that VU has to be equal to 7, because it's congruent to WV. So that means that it is 7 plus 7, which is 14 for the length of WU.